Now in the problem we can find IO as II into the same equation RD upon RD plus RL GM RSI upon 1 plus GM RSI. Can say VO is nothing but IO into RL, right? So we can write it as II into RD into RL upon RD plus RL GM we have already found upon 1 plus GM into RSI. RSI value is given in the question. RD, RL, all values are given in the question, and the current is specified as 100 micro ampere. So 100 into 10 raised to minus 6 sine omega t. RD is 4 kilo ohms. RL is 10 kilo ohms upon 4 into 10 raised to 3 plus 10 into 10 raised to 3, that is parallel value. GM we know 2 into 10 raised to minus 3, 50. So 1 plus 2 into 50. So this will give you it as 100 into 10 raised to minus 6 sine omega t into 2.828 into 10 raised to 3. So this will give you 0.282 sine omega t. This is your final output voltage which is asked in the question. So in the problem asked to find the voltage, not the voltage gain. Now we are left with only the input and output resistance. We can find the input and output resistance. We can say common gate circuit has low input resistance as compared to the common source and source follower amplifiers because of the transistor. If the input signal is current source, low input resistance is an advantage, you can say, right? So I can write Ri, or the input resistance, is nothing but input voltage upon input current. Input voltage is nothing but equals to minus VGS upon, we can say, II. How come? When you look at the diagram, the Ri is the resistance and the voltage is VGS and current flowing is II. So it is written as minus VGS because negative is connected over here and positive is connected to ground. So we are writing it as minus VGS upon II. Can say II is nothing but minus GM into VGS. This I have already told you, because you have current II flowing in this direction and GM VGS is flowing in this direction. So when you apply KCL at point S, you will get this relation. So when I substitute this in 1, what I will get Ri as minus VGS upon minus GM into VGS. So I am getting it as 1 by GM. So whatever value you have for GM, inverse of that will be your input resistance. This is how the input resistance is found out. Now output resistance, what we do for output resistance, we make Vi to be 0. When Vi is 0, we can say VGS will be equal to minus GM VGS into RSI, which implies VGS is 0, or we can say VGS into 1 plus GM into RSI equals to 0. Therefore GM into VGS is 0. Since Vi is 0, your VGS is 0, and VGS is 0 implies GM into VGS is 0. Therefore you can say output resistance is independent of GM. It is only depend on the drain resistance RD. This is how we are finding the output resistance for common gate configuration. Thank you for watching in 5 minutes. For further concepts, kindly keep watching in 5 minutes.